This is a Python tutorial to place images onto a map. We're going to start with a brand new project. We're going to use UV, an alternative to pip, to start a new Python project with UV init and the name of your project. We'll change directory into the new project folder, and we're going to add the Python packages that we will use in this tutorial. The primary one is the UI, which is called Shiny. Shiny is a pure Python program. We're also going to use Shiny widgets so that we can use ipyleaflet, which will be used to make the maps. Finally, as part of this tutorial, you'll learn how to use Pydantic, what Pydantic is, and why you might want to use it for data validation. This is intended for people that want to use Python for data analysis in the future. We're going to activate our virtual environment. We're going to start up an editor. And because Shiny is a server and front-end back-end system, we're going to change the name of main.py into app.py. This is just by convention. We're not going to need the code in there that was automatically placed in there by UV. We'll import the Shiny framework, the UI, and the app packages. There are two parts to a Shiny application, the UI and the server. We're first going to construct the server by setting it to a variable called app UI. We'll use the Shiny package UI.page sidebar. So this will be a application with a sidebar on the left-hand side. Within the page sidebar, we'll construct the sidebar itself. UI.sidebar. You can now use this HTML-like syntax here for UI.h2, which will be the heading 2. It's just be a piece of text that's a larger size for the heading. So we set up the UI with variable assignment. We're going to set up the server as a Python function. Their Python function will have 3 parameters: input, output, and session. This will be passed to the server function when we do the app instantiation. We're going to assign the app, the instantiated value of the app to the variable app. So app with a capital A, in there we'll pass it the UI, we'll pass it the server. Okay, we now have a full stack Shiny application, all in Python, that currently is displaying only one thing. It's a string of an H2 size. Let's set up our data model. We're going to use Pydantic for the data model. The model of data is basically the format that all your data will be in. This is most useful if you were to import the data from a database, but to get you used to Pydantic prior to accessing the database, we're just going to use Pydantic with a data that is embedded into the application. So the data model is a class and extends the base model class of Pydantic. We're going to call our data class tourist spots because we're going to place images that tourists might go to within Palo Alto. In Pydantic, you assign each of the properties of this piece of data a data type. We're going to create a list of all the spots that tourists might go to. So for each tourist spot is in a list, and we're going to have to instantiate each piece of data. Tourist spot is a class in Python. And so by calling the name of the class with the properties of the class, we can instantiate it. So this tourist spots is a list of Python objects, base model. To get the GPS coordinates very quickly, I'm not going to parse it from the image itself. I'm going to actually use Google Maps, and I'm going to select the location on Google Maps where the image was taken. And then within the URL in the browser bar, we can find the GPS coordinates as decimal placed GPS coordinates within the URL itself. So I'm going to copy that into the clipboard of my computer. I'm going to paste it into the body of the editor, and we specified that each tourist spot has a lat, L-A-T, and a lon for longitude. We're going to set those equal to the latitude and longitude of the image. There are a number of Python packages that can extract this image, the metadata, which includes the GPS coordinates from the image. However, for simplicity in this tutorial, we're first going to just hard code the latitude and longitude into each image. We're going to need the choices of the location. So if we have more pieces of data in here, we're going to have a list and a drop-down selection menu for the choices. So we're going to extract the name of the tourist spot, which is an object. And we'll use it for spot in tourist spots. And then each spot will have a name property. So we'll access it with spot.name. Now within the UI, we can create an input selection. So input underscore select. And within there, we can drop in the list of the choices, which was automatically created from that for loop on line 17. So the input selection has an ID that we'll use when we output it to or interact with the server. And we'll choose the location, which is the title or the label of the selection section. And there's a property called choices, which takes a list. We've already created the list from tourist choices on line 17. And to be clear, I'll put the name of the parameter. So it's label equals choose location. I think it'll find it by the position of the parameter, but it'll be easier to understand this way. Okay, we have our location drop-down menu with the input select on the right-hand side of the editor. It's looking good. We're going to use the shiny widgets so that we can use the map widget. And we're going to import an output underscore widget and a render underscore widget, which will be used to handle the output and the rendering of the widget. The widget that we'll create is a map from ipyleaflet. So this ipyleaflet is the package that interacts with the free map systems that we'll be using. Our application consists of two main panes. It has the sidebar, which we're using as the UI or the controlling mechanism for our map. And on the right-hand side, if it's a larger browser width, it will be the map itself. Above the map, I'm going to put an H2 title called Palo Alto Tourist Spots or Palo Alto Tourer. So this is going to be right over the map. You can't see it right now because the right pane of my editor is a bit small, and we have to also insert it. Okay, let's now get the map to appear. We're going to the server function. We'll use the render widget decorator so that it can render the widget. And we'll create a function called map. And within the map function, I'm first going to set up the OpenStreetMap, which I'm going to assign to a variable called OSM. ipyleaflet actually has the maps from XYZ services. So to be clear on the import, I'm actually going to use it from XYZ services. I'll import the providers for the different maps that we're going to use. So in the server, the function for the map, I can now assign the OSM to the provider from the XYZ services. So the providers is from the XYZ services. If you look at the documentation, it's OpenStreetMap.map nix. There's a whole bunch of different maps here, and you can go to either the ipyleaflet documentation, which has some of the documentation from XYZ services, or go to the XYZ services documentation directly. So it's one of the properties of the providers for OpenStreetMap.mapnik. Okay, to center the map and to put the marker there, I'm going to need to grab the coordinates for the longitude and latitude. But because we have it in a set of objects in a list, it's going to be a bit more involved in how we extract the data out. It's more real world, but it's a bit more complicated than if it was just in a dictionary. So we're going to assign a variable for selected name to the input dot spot name. So that input is from the UI, and the spot name is what we have as the selector. The ID for that dropdown is spot_name. And using that ID, we can now get the value of the selected spot, whatever you choose in the drop-down menu. But we want to grab the longitude and latitude when from that object if the name matches the selected name from the drop-down menu. So if you select Baranda Lake, we're going to put this thing into a for loop, and we're going to have an equality check. So if it's equal to Baranda Lake, in this case, it's going to then go back and send the spot back, and then with the spot, you'll have the selected spot. And remember, the spot is the object with the longitude and latitude in it. So it's not just the name of it, it's the object that has the information that we want to associate with the location and picture. Now the spot that we have on line 40 is the same spot that we've chosen on the drop-down menu. We're matching the name of the spot in the object with the piece of text that was selected on the drop-down. We're going to assign the latitude and longitude to spot.lat and spot.lon. And just to make sure that it's working properly, we'll test it out and print out the contents to the console to make sure that it is extracting the location correctly. And we can just visually check it with our data. Since there's only one data point at the current time, it's easy to check and make sure that our program is working as expected. So we have hooked up the drop-down menu with our data, and there is type checking on the data or type validation thanks to Pydantic. Now let's work on the map. I'm going to assign it to a variable called tourist_map, and we'll use the map from ipyleaflet. The map has a property for the center, which is the latitude and longitude in decimals. And we'll use the base map, which will be the OpenStreetMap that I just instantiated or assigned on line 43 from the OpenStreetMap.mapnik. If you recall, the UI is waiting for something to return from this function map that we defined, and we have reserved a space in the UI for the map. So the name of the function is the connector point between the server and the UI front end. And now we can just use this fully functional map. We'll set up a marker, and this marker will be the location that the picture was taken, which will be in latitude and longitude. So this lat and lon is we're going to pass it to the map in the form of a marker. And the marker will also have a title, when you mouse over it. So it's going to be the name of the location that we have as part of the object. And we'll just add the marker to the map. And now we have it at the precise location. This ipyleaflet has a nice zoom in the upper left, and we can see the location. You can also move it around if you want to. And you can kind of see that there's a very small lake there. There's only one location that we have. If you zoom in, it does look blue. And it says Baranda Lake, a very small lake. So we can't really get a sense of what the lake looks like. So I want to attach an image to this location, but I want to store my images in a folder called static and not www, because I think static is more commonly used for Python backend developers. So just to make the Python developer more comfortable, I'm going to assign a variable static underscore directory to the path where we're going to store the static files. Static files are the photos in this case. So we'll get the path of where the static files are. And then when we instantiate the app, the Shiny app, will have a property static underscore assets that we'll assign to the location that we set up. It's going to be in /static. That's how we're going to refer to it. And it will be linked to the static directory, which we just assigned earlier. So I will create that folder called static, and I'll put some images in there. These are just images from Palo Alto. And within the editor, you can check to see if the image looks normal. And within the tourist spot data model, I'm going to add a new property called image, and it's going to be of type string, because we're just going to store the location of the image, not the actual content of the image. And this is very common when you're developing server-side applications. You refer to the location of the image and use that location to display the image. So if you were to build a full-blown application, most likely the images will be stored on a separate storage system, such as AWS S3, and you'll just put the link to that image within your model. But right now we're using the location locally. So it'll be static /baranda.jpeg. So the current time we're not displaying the image, and we only have one piece of data in our test data. So before we get too far ahead of ourselves, I want to put another piece of data in just to test to make sure that this drop-down menu is actually working and sending the different types of data to the server application. So I've prepared another piece of data for the Baylands. The Palo Alto borders the San Francisco Bay, and that area around there is called the Baylands. And there's a picture of a park near the Baylands. Okay, so if we zoom in on it, we can see that it's not right by the lake. This body of water is the bay itself. And because the default zoom, I think is set to 12 with ipyleaflet, I have to zoom in every time to test it. So I'm going to set up a zoom slider bar in order to set the zoom, and then it'll save the zoom level for the duration of the session, unless I change it again with the slider. So I first need to create in the UI section of our application a UI element that will handle the user interaction. So human to computer interaction will be with this input slider. So once the human sends it to this UI portion, the UI has to send it to the server, and there's an ID in Shiny architecture. So the ID is actually the word zoom, the string zoom, and zoom level is the label that we're going to have over the slider. It's going to range from 4 to 20. And now within the map component, I can add a zoom onto it. So one of the properties of the ipyleaflet map is called zoom. And it'll be the input zoom with the round brackets. That input dot zoom, that second zoom there, is the name of the ID that we specified when we created the input slider. So now that when I test it, we can clearly see that it's a different location in the Palo Alto Baylands Park or the Foothills Nature Preserve Park in Palo Alto. And we can also see on the map that there is a nice set of trails. However, you can't really get a feel for what does this place actually look like. So we want to put some images on there. We'll first create another tourist spot for the Foothills Park Interpretive Nature Center, which has a small amount of kind of like a nature museum type of exhibit. So the Foothills Park Nature Center is actually, you're starting to feel looking at the center. And I should probably move that GPS coordinate over, right over the interpretive center, but I think it's close enough for this tutorial. We have our dock that we refer to as the T dock of Veranda, because it looks like a T. And we're going to put some space here at the bottom for some image, and yeah, maybe we'll just put the image for now. So I'll call the function that I'll create on the server spot_info. And we're reserving a space for that image in the UI. So now that I have the connector, I need to actually create the function with the same name that I specified in the UI. This function will be called spot info. So I'm within the server function. You can tell from the indentation. And within that server function, I'm now going to make a second function. The first function was for the map, the output of the map. But I'm going to make another function within the server function called spot info, which is also going to output and render some UI elements. That render on line 75, that decorator, I have to import it from the Shiny. I'll call it spot_info, and we'll assign the spot. We'll use the same algorithm that we used. Which is a for loop. And within the for loop, it's going to loop through the tourist spots, which was the data set that we created as a list of objects called a tourist spot. And we're going to check to see if the name in the list for that particular object is equal to the input spot name, which is that thing from the selector. So when we select a certain spot name, we're going to check to see if it's equal to each element of the list. And if it is, we're going to return it, or we're going to assign it to spot. So in the line 2, I need to import render so I can use it as part of the decorator. And now we're going to return from the function spot_info the UI element image, which has a property source src, and we'll assign that to the spot.image, which is a string that is the location of the image. And I set up this way so that we can add other elements in the future, such as notes or other pieces of information about this certain tourist spot. Right now, it has the location, the name, and the image. Because I'm using it as a pane and I have it magnified, so I have my editor at a larger font. Everything's bigger for the tutorial. That's why I have to make it wider to test it here. And the images are coming up beautifully. But I'll just put it into a full screen browser, since this will be actually our target, will be to put it into the browser. And it's looking quite nice. You have a much better idea of what this lake would look like, as well as the location of the lake. So we're on that T dock in this image. This is a park where it's a small hill, and the hill, from the hill you can see a view. This is the inside of the interpretive center, which has a small amount of like natural animal artifacts. This is a free tool, EXIF tool GUI. I'm showing you that the image I took with my mobile phone, an Android phone, iPhones do this too, it will store the GPS data by default. So I want to actually extract the GPS data from the photos that I took with my mobile phone on a fishing trip. I'm going to use the Python package GPS photo. I'm going to create a small utility to extract the GPS coordinates from the image on my phone from the EXIF data on it. So I'll create a small folder util. In there, I'll create another folder for photos of the photos I want to extract the GPS metadata from. I'll create a small Python script, get_gps.py, of which I'm going to use this package called GPS photo, which I just added from the Python repository. So first I want to get the path. So from pathlib, I'll get the path of where I am when I execute the program. And in this case, I've stored the photos in a subfolder off of where the application is running called Photos. I'm also going to import the GPS photos, which I need to extract the GPS data from the metadata of the image file, which is in JPEG format. We'll set up a for loop. So for file, which is the variable name here, it could be, you could use image or photo. So for file in the path photos, I'm going to use this .glob, which is part of path lib. And that says to grab all the files in that folder which match this string, which is, so the asterisk is match anything, it's the wildcard. Anything that ends in .jpg, which is all my images do, it's going to iterate through it. And each time through the loop, it will print the file name and the GPS data that's embedded in the metadata of the image, which I'm using GPS photo .get GPS data on the file, and I'm converting that into a string. And there is a couple of dependencies that I needed to install. PIL is Python Imaging Library. It's in the Pillow package. So add Pillow, and I need this PyEXIF. So I've installed all of it. I'll run it, and I'll have the GPS data. In the current simple architecture, the data is embedded in the app. So that list of objects is the data, and the images, so the actual files of the pictures, they're stored in the static directory of the application. This also has no authentication. In the future, we can store the actual image files in something like S3, and in that case, images can be uploaded through the application and stored on the remote server. Instead of having the data be in a file, we would most likely put it into an SQL storage, such as AWS RDS, which is a hosted PostgreSQL server. We can then use SQL Alchemy to have the Shiny application talk to the SQL server, and then use Pydantic for the data validation to make sure that what we're getting back from the server, the SQL server, matches the format that we need in our application.